So let me wait 1 more minute, then I will start, okay? Last one of the Yeah. I will try. I have updated the document. You have seen that, right? Yes. I have updated the document, added something, and then maybe next class, I'm going to discuss a lot of problems. And then your exam will be starting Thursday after next Thursday. Thursday after, so in 2 weeks. Yeah, so Thursday after next Thursday, your exam will be, and it will be open for how many hours? 72 hours, okay? So let me go. October 9th? I think so, yeah, October 9th, it will be open, and then October 9th, it will be open. It will be open for until 11:59 of Sunday, 12. Okay. Then maybe October 9th, there would not be any class. I just want you to practice by yourself. But I might maintain office hour during that time. If you have a question, you just jump in. But there is no physical class October 9th, okay? But if you want me to come and have class, that's fine also. I can do that. But I just want to give you some relaxed time. Okay, so let me start where I stopped last time, okay? I discuss all of this problem, combination problem with basic principles of counting, sample space, sample points. This is what I discuss. I discuss set theory, okay? Union of two sets, intersections of two sets, and then I discuss complement of a set, and then I discuss random variable, what is probability and what is the difference with possibility, and then I discuss sure event, impossible event, total probability, and then I discuss some. Now I want to discuss something that I did not discuss. So total probability is equal to 1, right? Total probability is equal to 1. Suppose if I have these things, x is a random variable, draw, and I want it to be x is a random variable, and here is my px, okay? And x takes value 1, 2, 3, 4, and 5. And 1, 2, 0.2, 0.3, 0.1, 0.2, 0.3, 0.1, 0.05, 0.05, okay? And what is this? Okay? What is that one? How can we compute the probability of x equal to 5? Here x equal to 1, x equal to 2, with the corresponding probability x equal to 0.3, x equal to 4. What is that? So what is probability of capital X equal to 5? What is that probability? How can I find that? 1 minus 0.2, 0.3, 0.1, and 0.05, right? So which will give us 156.65. So 1 minus 0.65 equal to 0.35. So this is equal to 0.35. So what you have learned, total probability is always equal to 1. In the probability space, or the outcome of the sample points, each sample points in the sample space will have a probability, and then if you add them up, total probability will be equal to 1. Okay? So total probability will be equal to 1. This is what you have learned. Okay? After learning these things, now I want to discuss about
how to find. Okay, now take a look at that. Suppose this is your mean you computed, right? X bar equal to sum of xi over n. This is the one way you can compute the mean. Or if your data is given in the format of a frequency table, then you can compute your mean by using this formula, right? You can use this formula to compute the mean, estimate the mean. This is what we discussed in our first exam material document. If you have a data in the frequency distribution table, you can use the formula that is written in this one. And if you have the X value, you can compute this. Now the question is, if your data is given in this format, if your data is given in a probability distribution format. So this is the probability distribution. X is a random variable. Each outcome of the random variable X has its associated probability. Probability of appearing 1 is 20%. Probability of 2 is 30%, right? So now the question is how to compute mean of the random variable X. Understand? So the formula for computing the mean of the random variable X in such a case would be you can compute mean, which is known as the mean or average. Most importantly, when you speak this type of mean by expected value, then anybody will understand that this is coming from a probability distribution. Okay, expected value or expectation, these are the same thing, or mathematical expectation. Let me be clear. If someone tell you mean or someone tell you average, it could be in data format or it could be in a probability distribution format. Okay. But if someone tell you mathematical expectation or expected value, you immediately think that this is average, but it is coming from probability distribution. What is probability distribution? Random variable X with its associated probability are given. That is called the probability distribution. Understand? Probability distribution means random variable has a specific values, a set of specific values together with their associated probabilities. So if you work this way, someone say expected value, then you will say that, well, as expected value is saying, so must be values of the random variable with their associated probability are given. Okay, in such a case, you must not think that you are given only the data point x1, x2, x3. Understand? Okay, so that's the main difference. Now, what is the formula? The formula for mathematical expectation is written: expected value of x is computed by sum of x and p of x. Okay, so x takes value what? 1 to 5, right? 1 to 5. So what is the first value? 1 times 0.20, and then second one is 0.30, and then third one is 3 times 0.10, and fourth one is 4 times 0.05, and fifth one is 5 times 0.35. This is the definition of mathematical expectation. Okay, x times px. So let me come here. This is the definition of a mathematical expectation. Clear, right? X times p of x. X equal to 1 times probability 0.20. X equal to 2 times probability 0.30. X equal to 3 times probability 10. Plus x equal to 4 times probability 0.05. Plus 5 times probability 0.35. Okay?
Are you understanding these things? Gentlemen, how are you? Or something. I already discussed mathematical expectation. But don't worry, I'm recording it, okay? Clear, right? Okay.
This is called the expected value. So remember when someone asked you, okay, here is the thing, the trick. I gave the data and the probability, and I ask them find the mean of the variable x. When the people do, they just take the values of the x and find the average. That will be wrong. Understand? So I can say that, well, this is the your probability distributions. Find the average of the random variable x. So you will have to apply this formula. Okay, this is the expected value. Now I want to find the expectation of x square. Now I want to find expected value of x square. Okay, which is x square probability of x. Okay, so now what I'm going to get in here, x takes value 1 to 5. If x takes value 1 to 5, I have to write here 1 square times 0.20, 2 square times 0.30, then 3 squares times 0.10 plus 4 square times 0.05 plus 5 square times 0.35. Clear? Okay. I want one of you to help me compute these things. And if you cannot, let me do it by myself. Where is my R? Here is my R. Here is my R. Okay. So I have 1 times 0.20 plus 2 times 0.30 plus 3 times 0.10 plus 4 times 0.05 plus 5 times 0.35. My average or expected value is 3.05. Okay, 3.05, which is equal to 3.05. Now, what is this? That could be obtained by 1 square means 1, 2 square equal to 4, 3 square equal to 9, 4 square equal to 16, 5 square equal to 25. Then I got 11.85. Okay, 11.85. This is what I got. 11.85. Okay, 11.85. So now variance of x could be obtained by expected value of x square minus expected value of x whole square. Now, what I want to do, expected value of x square equal to 11.85, and this is 3.05 square. Then I have 11.85 minus 11.85 minus 3.05 square. I have 2.54. I have 2.54. I have 2.54. This is the variance. Clear, right? Okay. Now let me again little bit. I want to give you some refresh. Take a look at that. If your data is given like this way, x values, x size value 5, 6, 9, 10, 15, 20, 3, 9. If this is the way values are given, then you can find the mean by using this formula. Okay? Sum of xi over n, and variance you can compute, variance of standard deviation, you can compute, suppose variance, you can compute by using this formula. So this is called non-parametric mean and variance. Data. From the data, you are computing mean and variance. Clear? Non-parametric. There is no nothing I can use. I just use the formula. On the other hand, if your data is given in this format, x and p of x, this is called the random variable x, which take value 1, 2, 3, 4, and 5. Associate probability is given 0.20, 0.30, 0.10, 0.05, and 0.35. If this is the way, this is the way data is given, then this data is called then values of the random variable and probability for each outcome is called the probability distributions. Probability distribution of random variable x. If this is the format, then you have to find expected value. So that means mean, expected value you will find by using this formula. And variance you will find, variance of x you will find by using this formula, expected value of x square minus expected value of x whole square. So this is a non-parametric mean, this is the parametric mean. This is a non-parametric variance, this is a parametric variance. So why they are same? This is just a data driven. Okay, this is just a data driven. Okay, and this is has a structure. Parametric mean structure. What is the definition of parameter? Unknown constant of the population which we need to estimate. This is called the parameter. Okay. Okay, let me write 2, 3 definition in here so that you would not be confused. What is parameter? Parameter. Parameter, unknown constant of population. Unknown constant of population. Unknown constant of population is known as parameter. Okay, unknown constant of population. Okay. Now what is statistic? Not ticks. Statistic. Tick. Statistics. Any function of sample observation. Any function of sample observation, sample observation, any function of sample observation is called a statistic. Any function of sample observation. Okay. And now what is estimator? Any function of sample observation any function of sample observations by using which we can estimate population parameter. We can estimate population parameter is called estimator. And finally, another definitions, then I will move for another topic known as the estimate. Value of a parameter for a specific sample. Value of a parameter, value of a parameter estimated from a sample is called estimate. It's called estimate. Okay. Value of a parameter estimated from a sample is called estimate. So she took a sample, she estimated average amount of money spent for lunch by the USM student. So this is her estimate. But the same estimator you are using uses. So your one is estimate, her one is estimate, my one is estimate. And together all of this is called the estimator, which is general. General means formula by using which we can estimate the population parameter is called the estimator. Okay. So these are the discussions about how to compute mean and variance for the random variable X which has a probability distribution. Okay. Now I want to do these things. I want to compute something. Okay. So now problem A coin is tossed 4 times with sample space as below. Okay, with sample space as below. Okay, clear, right? So now I am writing in here X equal to number of heads. Number of heads. Okay. So now I have here 4 head, 3 head, 3 head, 2 head, 3 head, 2 head, 2 head, 1 head. Here is 3 head, 2 head, 2 head, 1 head, 2 head, 1 head, 1 head, 0 head. Do you agree with that? Clear, right? So if this is the sample space, I want to compute some probabilities. Okay. I want to compute some probabilities from there. What are these? exactly 0 head. Number 1. I want to compute the probability exactly 0 head. Exactly 0 head equal to 1 over 16. Do you agree with that? There are 16 sample point, only one sample point has a 0 head. Okay. And then I want to do next one is exactly 2 head, 6 over 16. Okay. Exactly 2 head, 6 over 16. Now I want to do at least 1 head. So 15 over 16, right? At least 1 head. So only one sample point that does not contain any head. Okay. And then I want to do at most 2 head. At most 2 head means 2 head, 1 head, 0 head, right? 2 head, 1 head, 0 head. So 11 over 16, right? Are you sure? Yes. At most 2 head. Clear, right? Anyone has any question? Nobody has a question? Then I have. Suppose the coin is tossed 10 times. Are you understanding? Instead of how many times? Instead of 4 times, I want to toss the coin how many times? 10 times, right? How many sample point? How can you compute this probability? If I toss the coin 10 times, the sample space will have 1024 sample point, at least 5 head, at most 3 head, exactly 3 head. How can you compute this? If you do not have a question, I have a question. Please provide answer. You understand the question? How many days you will need to draw the sample space that you will have 1024 sample point? At least half of the day. You understand? How can you compute this problem? Formulas. What's the name of the formula? Our forefather gave a very beautiful formula, which will be third exam materials known as the binomial distribution. Okay? Clear? It doesn't matter how many times you toss. Our forefather developed the things for us, so we will just learn from them. And secretly we will thank them. I know all of them are in graveyard now. Clear, right? Good. So you are understanding the materials. That's good. Okay. Now I want to solve a problem. A ball has 15 marbles. 7 of them are white. 5 of them are red and rest are green. So 12 are white and red, and remaining 3 are green. So 15 marbles. Suppose a person randomly choose 5 marbles, find the probability that all are white. Okay. I want to find what? I want to find the probability. Take a look at that. All are white. Okay. 2 are white and 3 are red. 2 are white, 2 are red, and one is green, at least 2 are white. Okay. Now, from the 15 marbles, so there are 15 marbles, 15 marbles, okay? 7 are white. So this is the box. 7 white, 5 red, 5 red, and 3 green. Okay. First of all, how many ways 5 marbles can be picked? How many ways 5 marbles can be picked? There are 15. How many ways 5 marbles can be picked? Randomly, how many ways? Okay. First of all thing, in the box, there are 15 marbles. Okay. I want to pick 5 marbles. How many ways this marble can be picked? If I pick 5 of them could be red, and then 5 of them could be white, 3 of them could be white, 2 of them could be green. Okay. So 5 marbles can come in this many ways. 15 permute 5 or 15 combination of 5. Answer me. Take 1 minute and answer this question. Which one should be used? Combination or permutation? Take your time. Take 1 minute and let me know. 5 marbles can be picked from a box of 15 marbles. Okay?
I think combination.
Combinations. Okay, I got you to answer combination. How about other people? Combination? How about you? You are going with the flow? No. Good. It is a combination problem. This is a combination problem. So I can do these things by using this formula. Choose 15, 5 by using the R, I will get the result. So this is not a permutation problem. Thank you. Okay. So now let me go and do this. Choose 15, 5. 3003 ways I can choose 5 marble. 3003 ways. Okay. Clear, right? 3003 ways. Now, first problem. Denominator is 3003. Second problem. Denominator is 3003. Third problem. Denominator is 3003. Okay. Now, first problem is asking you, all are white. All are white. If all are white, then what will happen in the numerator? All are white. How many white marble? All are white. So then, how many ways you can get 5 white marble? Yeah, because the question is all are white. That is 7 combination of 5, right? Because the question is asking you, okay, okay, listen, take a look at my God-given beautiful face. Okay. you are randomly chosen five marbles. So which is 15, choose 5, you got 3003. Which will be in the denominator? You are asked to find the probability. So denominator will have all combination, but numerator, now you are targeting that all of them are white. So 7, choose 5. You understand, right? You understand, right? So that means 7, choose 5. So 7, choose 5. You can use the R, choose 7, choose 5. Then you are getting the result in here. Choose 7, choose 5 divided by this 0.007. Okay. So your answer is 0.007. Listen, if you do not understand this problem, you can have an appointment with me. Okay. So remotely or in face-to-face, you can come, I can explain it you more. But now I have to finish a lot of materials. I'm going little faster. Okay. Now, second one is asking you 2 are white, 3 are red. 2 are white, 3 are red. So that means you are getting 2 white, 7, choose 2. Okay. And 5, choose 3. Do you understand these things? Yes. Okay. No. Yeah. So this is the answer, right? So why multiplication? Why not addition? Basic principles of counting. Understand? Because this and that white can come, this and that white can come, and this and that red can come like this. So if you draw the picture like this, it will happen. Okay? So this is basic principles of counting. Choose 7, choose 2 times choose 5, choose 3 divided by choose 15, choose 5. Is Excel easier or R easier? See, you are not getting any support from your classmates. So you got these things, right? So now come to the next one. 2 white, 2 red, and 1 green. 2. So that could be done by using 2 white, 7, choose 2, 5, choose 2, 3, choose 1, right? Which could be obtained by and then choose 3, choose 1. 3, choose 1. If you want, you can give another bracket if you want, but I think it doesn't matter because I put the division part all the way to the bottom. It's still same. Okay. Okay. And finally, at least 2 are white. So I want to see whether you can, oh, I already solved it in here, right? So at least 2 are white, at least 2 are white. So come in here. If I want to do at least 2 are white, 4, denominator is still 15, choose 5, at least 2 are white. So 7, choose 2 times, and then there are 8. 8, choose 3. And then 7, choose 3. And then 8, choose 2, right? And then 7, choose 4. 8, choose 1. 8, choose 1. And then 7, choose 5. 8, choose 0. 8, choose 0. Are you understanding these things? Looks like you are lost. Okay, take a look at that. At least 2 are white, right? At least 2 are white. Then how many remaining? 8, right? There are 7 white ball and 8 green and red ball. So if 2 is white, then remaining 3 must be green and red, right? And then if 3 is white, remaining 2 must be green and red, right? Are you okay? You get it now?
You said at least.
At least.
So white could be 2, 3, or.
All 5. If white all 5, then there is nothing from green and red, right? So that means here 8 choose 0. Here is 8 choose 0. Here is 8 choose 0. It should be 8 choose 0. How can I write in here? 8 choose 0 times this 8 choose 0. Clear, right? Good. So many of you do not have a very good math or statistics background. I give all the combination. It is just a 12-page document. All types of materials I'm making it. I'm not giving you a lot of materials and keeping you super busy. Do this homework, do this project. No, I want to what you have, whatever you want to learn perfectly. Okay, small scale, if grow interest within yourself, then you can go to the next step. Then you can go to the next step. Okay, so now how can you solve this problem? This problem you can come in here in the R if you want to use these things. Choose. I have 7, choose 2. Okay, 7 choose 2 times choose 8 choose 3 plus. Okay, I have to put here a big thing. Then I want to put here another big thing. Then I want to put here choose, and then 15 choose 5 in the denominator. And then I will keep adding in here. Copy. So here is 3 and 8 choose 2. And then I want to put here another one. 3, 7 choose 4. 8 choose 1. And then 7 choose 5 and 8 choose 0. No, it's separate on ignore. So are you saying I'm putting a big bracket in here? So this is the beginning, and this is the ending of all numerator part. and then rest of them I'm just adding. Okay, hit enter, you will get this result. Okay. R and Python are the two very beautiful creations by some people in 35 years ago. 1990, 1991, these are developed in Auckland, New Zealand, and in Netherlands. Okay. Before that, there was a S plus, and some talented guy, they come up with this idea, they develop these things, and now S and S plus become obsolete. So previously it was just like a MATLAB. Okay. It was just a MATLAB, and a lot of money was making, doing good business. Now people no longer use those things, S or S plus, because R and Python people are using. Is this your first time you are learning R? You know R before. Okay. But 1, 2, 3, 4, 5, like both of you are learning. Okay, good. Okay, after that, this is done. Now I want to discuss something. Independent is a very good thing. Okay, independent. Now I want to draw a graph like this way. Okay, A and B. It is a two coin tossing experiment. Two coins tossing experiment. Okay. So suppose this is your HT, HH, and TH. Okay. This is A and B, two events. Two coin tossing experiment. This is another one. This is A and this is B. So here they do not touch each other. Let me erase these things. Let me erase these things. Oh, it's going outside. So here is HT and here is TH. Here is HH. Here is TT. Okay, sir? My local language is called ঠিক আছে, and then in English we call it okay. Okay. Are you saying two Venn diagram? These diagram are called the Venn diagram. Okay. This called the Venn diagram. Two events A and B. This is the figure 1 and this is the figure 2. Two coin tossing experiment. I draw two Venn diagram known as figure 1 and figure 2. Two events A and B and two events A and B in the two different figures. Now my question. Are events A and B independent in figure 1 or events A and B independent in figure 2? You understand? What are the events in A? The events are at least one head in event A. Okay. And event B in the figure 1, at least one head also in the figure B, right? Or in the figure 1, you can say first coin is a head and then B, second coin is a head. In figure 1, event A stands for first coin is a head. In the event B of the first figure is a event where second coin is a head. Understand? So two events in figure 1 are independent or not? Saying you said yes. Okay. Now the second figure, two events, events A, which stands for one head, and figure B stands for both head or both tail. Okay. So by looking at the figures in 1 and figure 2, if I ask you the question, are the events A and B independent in figure 1 or the events A and B independent in figure 2? What will be your answer?
1.
You said in both cases, event A and B are independent. Okay, I got two answers. How about your answer? Events A and B are independent in figure 1 or events A and B are independent in figure 2 or both figure events A and B independent? What would be your opinion? I got their opinion.
I'll say figure 2, they're independent.
Independent. How about you?
Figure
Figure 1. Figure 1 A and B are independent. Yes. Or how about you? Figure 2. How about you? Figure 2 A and B are independent or figure 1 A and B are independent? Figure 2. Okay. How about you? Figure 2. Figure 2 A and B are independent. This is all. Okay. Did you already read the materials? No. Okay. Then here is the answer. Figure 2 A and B are not independent. How? There is a mathematical formula. That formula will justify. Okay. Do you understand? If in the question I ask you test whether events A and B are independent, you cannot make decisions by looking. Okay. There is a formula you have to run through. But if this type of figure is given, immediately you say figure 2 A and B are not independent. Okay. Figure 2 A and B are not independent. That is mutually exclusive, very dangerous. America and Russia. Do you understand? Yeah, figure 2 A and B are not independent. Figure 2 means America and Russia, or maybe North Korea and South Korea. Yes, that is what I'm going to show you now.
Would it depend on the test you're
There is a formula. You have to compute those things and then you have to make a decision. Clear, right? Okay. But anywhere rest of your life, if you see a Venn diagram and a figure like this, so they do not touch each other, they do not intersect, they do not share, that is the most dangerous thing. That is called the dependent. This is what saying then, oh well, so you and me are gambling, 2 coins. If both of them appear like this, I will win, or one head appear, you will win. Understand? So that is mutually exclusive, right? So that is dependent. So now let me show you the formula. Two events A and B, two events A and B are said to be independent, if joint probability of A and B, probability of A and B, this is called intersection, okay, A and B. it is written probability of A and B equal to the product of their individual probability or marginal probability. If this is equal to that, then we can say that two events A and B are independent. Now we are going to compute them, okay? Take a look at these are the same thing. This means A intersection. This is the notation of intersection. This is called intersection notation. Intersection. Okay. If this and that are the same, this is also known as the AND. Okay. This intersection means AND. Okay. Now let us go and compute for the figure 1. Okay. Figure 1. Figure 1, we want to compute probability of A and B. A and B, okay? So probability of A and B has only one sample point, which is HH, right? So HH equal to 1/4, right? Now probability of A in the figure 1, which has two sample point, which is equal to 2/4. Probability of B in the figure 1 has two sample point, which is equal to 2/4, right? Now probability of A times probability of B, which is equal to 2/4 times 2/4, which is equal to 1/4. So these things exactly equal to that. Okay. So that means in figure 1, two events A and B are independent. Clear, right? Clear, right? Exactly same, right? Probability of A and B equal to probability of A times probability of B. Got it, right? Now, what you will do, you will never forget this definition. In the exam, I'll ask you check whether these two events are independent or not. You will compute their joint probability and check whether that joint probability is equal to the multiplication of their individual probability. Individual probability also known as the marginal probability. Okay. Okay. Now in the figure 2, probability of A and B equal to 0, right? Probability of A and B equal to 0 because A and B do not share anything common, right? Come in here. Is there anything common A and B? A and B doesn't have anything common, right? So probability equal to 0, right? Now probability of A in figure 2 equal to 2/4, which is equal to half, and probability of B, which is equal to 2/4, which is equal to half. Clear? Now, probability of A and B equal to 1/4. Are they independent? No. 0 is not equal to 1/4, right? Most easiest way, I explain you what is independent in. Independent means they do not depend each other. Okay. After discussing this thing, this is what I discussed: Venn diagram to coin tossing experiment. So this is all I discuss in here. Now, I want to discuss you these things. This type of event could be independent, could be dependent. Okay. So figure one and figure two. Okay. So figure one, as it was mentioned before, H, T, H, H, T, H. I already showed that in this type of figure, A and B is independent. I already showed it in there. But this type of things could be independent, could be dependent. How? Take a look at that. This is HT, this is TH, and that is called HH, and this is called TT. Okay? TT. Now check whether A and B are independent in here or not in the figure 2. Figure 1, I already discussed and showed you that event A and B independent in figure 1. Now I want to show they are sharing one element HH, both had. I want to check whether A and B are independent in figure 2. Okay. How can I do that? In figure 2, if you do these things A and B, then you will see 1 over 4. Right? In figure 2. In figure 2, it is 1 over 4. In figure 2, probability of A equal to 3 over 4. And probability of B equal to 2 over 4. Right? 2 over 4. Now, if you multiply these with that, you will get 6 over 16, which is equal to 3 over 8. No, this is the second figure.
Yeah.
No, probability of equal to 3 over 4. A has a 3 elements, right? So 3 over 4. And B has 2 elements, so 2 over 4. So the multiplication of them will give you 6 over 16, which is 3 over 8. 3 over 8 is not equal to 1 over 4, right? Are you understanding? 3 over 8 is not equal to 1 over 4. So what you have learned, this type of event, let me take a color. This type of event could be independent, could be dependent. Okay? Because they are sharing thing. They are sharing thing. This is independent. Okay? But they are not sharing the thing. They are sharing the thing. They are independent. They are also sharing the thing, but they are not independent. Okay? So this is the definition of independent. When I ask you to check independent, you will do this. What is the formula? So this is the third formula that you have learned today, is check whether A and B are independent, could be obtained by checking these things. Previously, you learned the formula of expected value of X, and you have also learned the formula of variance of X. Okay. These are the three things we have learned today with a detailed explanation with the example. Okay. Now I want to find conditional probability. Conditional. Okay. Conditional probability means something already happened. What is the probability that another thing will happen or other thing will happen? That is known as the conditional. Conditional probability has a definition. You have to apply that definitions. So how can we write like this way? Probability of A given B. Probability of A given B, it is written as probability of A given B, which is written as probability of A and B divided by probability of B. This is called the conditional probability. So now if you ask me question, Professor, please give us an explanation. Are you seeing probability and there is a vertical line? What is coming after vertical line is already provided, is given to you. Understand? If I give you $10, go to the Walmart and bring for me a couple of pen and paper. I have given you something, right? So after the vertical line, we say that given, say probability of A given B. So what is the probability of happening A when B already happened? That is the explanations, interpretations of these notations, probability of A given B. Okay. So let us go there and try to compute something. Okay. So after that, we will do the this big problem. Okay. So I have given the explanation what is conditional probability in here. This is the, now let us solve this problem. In this problem, it is said a community has 300 persons. Okay, 300 persons. 100 of them are both players and adults. Are you seeing 100 of them in here? Players and adults. So these things was not given. Actually, this is given that problem. From that problem, we are formulating this. A community has 300 problem. 100 of them are both players and adult, which is this. 200 of them are adult. Okay. 50 of them are minors and non-players. 50 of them are minors and non-players. So these two, this and that are given. 4 informations are given. Okay. In a community, there are 300 persons. These 300 given. 100 of them are both players and adults, which is this. 200 of them adult, which is this. 200 of them adults. So these things, that things given. Okay. And then now these 50 of them are minors and non-players. Suppose a person is selected at random, find the probability that selected person is a player. Okay, so let me do these things. A community has 300 people. 100 of them are adult and players. 200 of them are adult. Also, 50 of them are minor and non-players. Construct a 2x2 contingency table. Construct a 2x2 contingency table, okay? So I want to put here players non-player. I want to pull here adult and I want to put here minor. So adult and player, there is a 100 and there is a total adult equal to 200. So 200 minus 100 and this is a 50 minor and non-player and total equal to in here total equal to a 300. 300 minus 200 equal to 100. 100 minus 50 equal to here is 50. What is the question? Yeah, so here is 150 and here is 150. So take a look at that. In your question, I provided these things, that things, that things, and these things. Rest of the things I just do computation, okay? The red circle thing I provided in the exam, in the questions. Now rest of the things are filled up. Now this is a 2x2 contingency table. This is known as a contingency table, okay? This is known as a contingency table. Contingency table. Contingency table, this is known as. Okay. Now see, how can we solve lot of problems from this type of table? In your exam, if I give you a problem like this way, first of all, you have to construct a contingency table, without constructing which you cannot solve any of the problems that I'm going to discuss. Clear, right? Okay. First of all, they randomly select a persons from these 300. And then first problem is a person is selected at random. Find that the selected person is a player. Selected person is a player. So how can we do that? This is a 300 and there is a player. Player equal to how many? 150, right? So 150. Okay. A person is randomly selected from the 300 persons. I want to know the probability that the selected person is a player. So there are 150 players out of 300. So this is like that. So number two, the selected person Number 2, adult and non-players. Adult and non-players. The selected person is an adult and non-player. Adult and non-player 100. Okay. Number 3, adult and non-player. An adult or player. An adult or player. Okay. Take a look at that. An adult or player. I want to find an adult or player. So what will happen? Probability of an adult or means union, okay? Adult or player. So this could be written as probability of an adult plus probability of a player and then minus probability of adult and player. Okay? Adult and player. Do you understand this formula? Okay. So if you do not understand these things, let me give you explanation. I am giving you explanation for the formula. Understand why these things? So suppose you have a one like this and another like this. Okay. This is a adult and this is a player. Okay. I am going to give you explanation why the formula is like that. Take a look at the board, please. When you write adult, so you are writing this entire thing, right? So that means this part is coming once in here. When you write player, then this part again coming in here, right? So this area is coming 2 times in here. And that is why I am subtracting 1 time. You understand this thing? If you write probability of player, this area is coming 1 time. If you write here probability of adult, this area is again coming. This area, let me put in here with the red color. This red region is coming twice. Once it is coming when you write like this, probability of A means all of this. And then this area is again coming in here when you write probability of player. So this area is coming 2 times in this 2 part. So I have to subtract 1. Understand, right? So now an adult or player. So probability of an adult, there are altogether 150 adult, right? 150 adult out of 300. And there are 200 adult. Oh, there are 200 adult and player is 150. I'm sorry. So let me write it in here. 200 adult out of 300 and 150 player, right? Yeah, 150 player out of 300. So this is for the player. This is for probability of player. and this is for probability of adult, okay? This is okay. Minus adult and player, which is equal to 100, right? Adult and player is 100. Okay? So what will be the answer? Answer equal to 300. 350 minus 100 equal to 250, which is equal to this and that cancelled out, which is equal to 5/6. Calling me. So my student as well as he is the faculty. Can I take the phone for a second? Hello, Masum. আচ্ছা আমি তোমাকে পরে ফোন করে আমি ক্লাস পড়াচ্ছি আমি তোমাকে 2 ঘন্টা পরে ফোন করব ওকে he is my student I'm doing collaborative research he is a faculty at San Jose State University so my direct student so he called me about the research I said after teaching the class I will call him back okay so now you saw that 2 problem we solved right now check whether minor and players are independent right check whether minors and players are independent. So in order to do that, number 4, probability of minor and minors and player, right? Minor and player are independent. Okay. So probability of minor and player. So I have 300 minor and player equal to what? 50, right? Minor and player equal to 50. Okay. So I have to put here 50. So then I have here 1/6. 1/6. Okay. Now I want to check probability of minor. Probability of minor equal to what? 100/300, which is equal to 1/3. And probability of player equal to what? Player equal to 150/300, right? So I have half. So they are independent, right? Yeah, independent, right? Are you ready to learn something? In a contingency table, if one case is independent, rest all of the cases are also independent. Understand? There could be 4 cases, right? Adult, minor, adult, adult, player, adult, non-player, minor, player, minor, non-player. In a contingency table, if 2 events are independent, rest of them all are independent. Okay? Listen, when you watch my video and class lecture, pay the attention. I have to test your knowledge, how much efforts and thought process you are giving to learn the material. Still, students are emailing me 95% thing. You said in empirical rule by. I said read that list. Yesterday I replied another student's email. Okay. The professor's main purpose is to give you the knowledge. I'm trying my best. Okay. So now come in here. So now they are independent. Okay. Yes, they are independent. Are you see? Yes, they are independent. A player given that he is a minor. A player given that he is a minor. A player given that he is a minor. How can you do that? Probability of a player given that he is a minor. Understand? So now you will have to write the definitions. Probability of A intersection minor divided by probability of minor. Okay? So what is the probability of the minor? Minor equal to 100 over 300, and a player given that he is a, what is the question? A player given that he is a minor. So I'm sorry, here it will be actually player. Here actually it is player. Here actually it is player and minor. So player and minor. So player and minor equal to what? Player and minor 50. 50 over 300. So that means half. Okay. This is the conditional probability. Right? Conditional probability. Let me see anything else. No. Okay. Clear, right? Okay. Now for this problem, I want to add another thing in here. Let me see whether it could be written in there. No, I cannot write in here. So take a look at that. Convert the contingency table to a joint probability table. Convert the contingency table to a joint probability table. Do you understand what I said? So what was we had in here? We had in here player, non-player, and here is total. Right? Here I had adult, and here I had minor. Right? So adult and player, how many? 100, right? So 100 over 300 equal to 13, right? How was it 200? 200 over 300 equal to 2 over? Non-player is what? Non-player is 100. So that means like this, right? And then this plus that equal to 2 over 3, right? Now here, what was in here? 50 over 300, which is equal to 1 over 6, right? And then how much is in here? 50. So 50 over 1 over 6, right? So 1 over 6 equal to 1 over 3, right? And then 1 over, then it is equal to what? 2, 4 over 6, right? If I multiply it by 2, 2 over 6, so 3 over 6. And then here, 3 over 6, right? 3 over 6, right? So this is equal to 1, right? Yeah, right? Now the probability that we computed, we can compute it much easier way from there, right? Do you understand what I said? The probability that we computed previously, we can compute this probability much easier way, right? For example, what was the first question? Can any one of you help me? What was the first question? A player, right? A random, find the probability that a randomly selected person is a player, which is equal to 3 over 6 equal to half. Okay, this is the number one problem. What is the second problem? Adult player, adult non-player, which is equal to 1 over 3, right? Adult non-player, 1 over 3, right? Then question number 3 was what? Adult or player, adult or player. So adult equal to 2 over 3 and player equal to 3 over 6 and minus adult and player 1 over 3, right? So which is equal to, if you put there, is this okay or not? Tell me again, tell me again, what is the question? Adult or a player, right? So adult equal to 2 over 3, player equal to 3 over 6, and then adult and player equal to 1 over 3. So if you put here 6, you will get there 4, you will get there 3, you will get there 2. So that means you have 5 over 6, right? So we are solving the same problem. First one is frequency approach. Frequency, I'm transferring it to probability. Second one, I have a contingency table. I converted it to joint probability table, and then I am computing all the probabilities. Okay. Then what is the fourth one? Minors and players are independent, right? So probability of minors and players. So probability of minors and player equal to 1 over 6. Okay. And then probability of minor equal to 1 over 3 and probability of player 1 over 2. So multiplication is equal to 1 over 6. Clear, right? Okay. All the questions is coming, what I'm discussing, word will be different, and then problem will be different. Okay. So if you do not understand fundamental of this, you would not be able to do well in the exam. Okay. Similarly, the next one is what? Conditional probability, right? The next one is the conditional probability, right? What is that one? 5, question 5, I think. Player, given that he is a minor, so I can find here probability of player and minor divided by probability of minor. Okay. So probability of minor equal to minor equal to 1 over 3. 1 over 3. And minor and player equal to minor 1 over 6. Which is equal to half. Okay. So this is the way you can do like this one. Okay. Now, after finishing this thing, we will do joint probability. Okay. How to compute joint probability, all of these things, and covariance, variance, all of these things. Okay. The next week we will solve all of this. Let me drink some water. You can take a 5 minutes break. Okay. Okay. Now, you remember I have shown you how to compute mean and variance from data-driven approach as well as by mathematical expectation. Okay, and this is expected value of x square minus expected value of x whole square. This is the mean where data use. This is the mean or average when the random variable X together with its probability is given. This is the data driven variance. This is the random variable variance, right? Now, this is the covariance formula that we use 1 over n minus 1 sum of xi minus x bar and yi minus y bar. Now, there is a formula. This is the covariance. Okay, covariance of x comma y is computed by using this formula, which was a first exam material. Now, how can we find covariance when there is a random variable joint distribution of x and y? Understand? So that is the formula. You can find covariance of x comma y could be obtained by finding joint expectation of x and y minus individual subtraction of individual expectation of x and y. This is the formula for the covariance when data is provided in terms of probability distribution. Two random variables with their associated probability are given, then how to find the covariance. Clear, right?
Why do we factor in n minus one for the top equation, but not the bottom?
Okay, the top one is the data driven. Okay, so if you ask me this question, then why in this case? Okay, let me write these things. This is the data driven or non-parametric mean, and this is the parametric mean or expected value xi minus p of x, right? There is no divided by n minus 1 or n. Okay, similarly, this is the variance 1 over n minus 1 sum of xi minus x bar square, and here the variance of x is expected value of x square minus expected value of x whole square. Okay, there is no n minus 1 in here. Okay, this is the left side one when you data is given. x1, x2, x3 is given. And here x1, x2, x3 as well as their associated probability are given. So here is the variance. Covariance is, it is written as x comma y. It is written as n minus 1 sum of xi minus x bar yi minus y bar. But here it is written covariance of x comma y is written expected value of xy minus expected value of x and expected value of x and expected value of y. There is no way that you can take something from there and put it in there. There are two different ways. And it was tested. It was very good because the parametric one where the structure is given, that is more realistic because each values of the random variable and together with their probability of happening are given. Okay. So now what you already did in this problem, you converted these things in a joint probability table and then computed the same problems directly the probability, okay, which you have just seen. Now suppose see in your exam, if you get a problem like this way, let x denote the number of horses being used on self-service island at particular time, and let y denote the number of horses on the full service island in use at that time in a service station. You understand x and y? One is known. Oh, one is known as self-service. Another one is full service. Okay, full service. So x is taken like in here y 0, 1, 2, and here x is 0, 1, 2, and these are the probabilities are given. Okay. These are the probabilities given. If probability is given, that is fine, very easy for you. But sometimes the probability is not given in this table format. Instead, it was said verbally in the question. Do you understand? Are you seeing beautiful table? X is taking 0, 1, 2. Y is taking 0, 1, 2. Instead of giving this very beautiful table or spoon feeding, I can tell everything by verbal. Okay, that self-service has no self-service has no who's active, but full service has two who's active with probability 0.02. Are you seeing? Do you understand?
Yeah, I was just confused because I read the question wrong and I was confused. I thought it said horses and I was like, huh.
No, it's who's.
Yeah, I was like, okay, it's like trying to follow. That was irrelevant.
Now,
I just misread it.
previously you read it as a horses?
Yeah,
Oh, okay.
I was laughing.
Okay. So are you saying instead of giving this probability, I can say that X is a self-service, right? The probability of no self-service uses and probability of two full service uses is 0.02. In this way, I can verbally explain all of the things. In such cases, you have to construct the table first. Without constructing table, you cannot complete the problem. Do you understand what I said? Instead of beautiful table, I can verbally give the problem, right? And verbally problem, you can write the beautiful table. After table construction is done, then rest of the problem is just like this, right? Understand, right? Okay, so now only what I will provide only these things. These 9 numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. And then if you add all of these, then this is that. If you add all of these, this is that. If you add of this is that. So, and then if you add the column, you will get this column, good, you will get this. Okay. Now compute the following. Now compute the following. What? Marginal probability distribution of X and expected value of X. So this is my X, right? So this is the marginal probability. If you add all of this, this is probability of X equal to 0 equal to 0.16. Probability of X equal to 1 equal to 0.34. Probability of X equal to 2 equal to 0.50. Okay. So this is what I constructed in here. The marginal distribution of X is given by like this. Clear? Now the expected value of X equal to 0 times 1.16 plus 1 times 0.34 plus 2 times 0.50, which is equal to 1.34. Clear, right? Now come in here. This is the probability. Okay. You remember I said individual probability. Individual probability or marginal probability is the same. When there is a joint, if you sum over the Y values by keeping X fixed, then it is the marginal for the X. Okay. So for example, take a look at that. I keep X equal to 0 fixed, and if I add all of these, this is the marginal probability for X equal to 0. Okay. Now come to the second problem, marginal probability distribution of Y. Marginal probability distribution of Y equal to, and the expected value of Y equal to this. So which we computed in here. This is the marginal distribution of Y is given like this. And then I have computed expected value of this. Okay. Maybe I can add here a few more things like the variance of X. Variance of X you can also compute. Okay. After that, now come to the third problem, joint probability of x equal to 2 and y equal to 1. X equal to 2 is this, y equal to 1. So which is equal to 0.14. Joint probability. Clear? Joint probability. Remember, let me tell you again, in your exam, maybe you can get 5-6 problems from one of these, but the beautiful table that you are seeing, it will not come in that format. Instead, I will provide the problem in a what format. By what format? By thinking, you will have to use your intellect well. So there are few more informations given. Let us go and do the constructions of the contingency table or join. Without constructing join table, you cannot compute the probability. Okay, during the exam time, do not be like the professor gives something that he did not discuss. All the problems is coming from there. So if you see something is not catching, think about contingency table. Think about joint probability distribution. Yes, gentlemen. Yeah, there are, at the end, I already put lot of sample problems. Yeah, some of them are wording also. Some of them are. Yeah, some of them are wording. Maybe today I will also discuss one or two problems because I have time. Okay. Now, probability that y takes at most 1. Y takes, no, conditional probability x equal to 2 given y equal to 1. Okay. So come in here, the notation x equal to 2, y equal to 1. Which is the definition is this, x equal to 2 and y equal to 1 divided by y equal to 1. This is the definition. So x equal to 2 and y equal to 1 is getting what? X equal to 2, y equal to 1, I am getting 0.14. So I put here 0.14. Take a look at that. I put here 0.14. And y equal to 1 equal to 0.38. Y equal to 1 equal to 0.38. Are you seeing that thing? Okay. So these divided by that equal to 0.36. Now, y less equal to 1 given x equal to 2. Okay. So y less equal to 1, y could be 0, x equal to 2, y could be 1, x equal to 2. So this is the way this could be written. Are you understanding these things number? This one. I'm saying y less equal to 1, right? Y less equal to 1, y could be 1, y could be 0. Y have three values, 0, 1, 2. So that is why I write here y equal to 0, x equal to 2, and x equal to 2 is given. So then y equal to 1, x equal to 2. So what I am getting? I am getting that. Okay. And then I use the formula of conditional probability. And conditional probability formula I have, then corresponding to those two, I just provide the number and divided it and got the result. Okay. So after this, now x given y equal to 2 can be obtained by dividing each entry of column. Okay, now see, take a look at that. You have to understand these things. I want to find the conditional distribution of x when y equal to 2. So this part, the way I have written in here, this should be actually given. So let me go there and change it in here. Okay, I will change it. So the notation that you are seeing x minus 1, this notation actually, this will be vertical line. Understand? Okay, please take a look at the board. Are you seeing this should be actually vertical line. This one should be vertical line. Okay. This line should be vertical line. This should not be x minus y because I typed it in the LaTeX. So I have to fix it. So take a look at that. When y equal to 2, what will be the distribution of x? So when y equal to 2, we can obtain by dividing each entry of column y equal to 2 by the total of column 2. So if you take a look at this one, this is probability of y equal to 2 equal to 0.38, right? 38. Now I want to divide x is this is my x's, okay? When y equal to 2, given what is the distribution of x? We have to divide it by 38. We have to, because this is the x value, okay? This is the x value divided by 38 divided by 38. So that is why it is mentioned in here 0.02 divided by 38, 0.06 divided by 38, 0.30 divided by 38. Can be obtained. Here I wrote here conditional distribution of x. That means I want to find the conditional distribution of x when y equal to given y equal to 2. So in order to find this, you have to, this is the joint, right? Joint of x equal to 0, y equal to 2. This is the joint of x equal to 1 and y equal to 2. This is the joint of x equal to 2 and y equal to 2. So each of the joint will be divided by the marginal. So because y is given as a 2. So that is why we have mentioned in here, this can be obtained by dividing each entry of the column of y equal to 2 by the total of column 2. Total of column 2 equal to 0.38. So each of this I divided, I got this. Okay. So now I want to find the joint expectation. Joint expectation means what? Expected value of x and y. X takes value 0 to 2, y takes value 0 to 2. It should be y, it should not be x, okay? It should be y. Take a look, this is the typo. I will fix it tonight and then again upload it, okay? I will fix this one, I will fix that one. This is equal to y equal to 0 to 2, understand? This one, this here equal to y equal to 0 to 2. Okay? Y equal to 0 to 2. Now if it will go 0 times 0, so all the 9 probabilities in here, this times that times this times that times this times that times this. Fortunately, 0 times anything will be 0, right? So that means I do not need to be worried about first row and first column. I just need to be worried about these, that. Why? Because 0 times anything equal to 0. Clear, right? So that is why when I am multiplying these things, I need to actually multiply. So I got the joint expected value equal to that. And then this is equal to 1.66 and expected value of x and expected value of y I already found in here. Here is the expected value of x. Here is the expected value of y. I found that this is the formula that I use to find this. Okay. Now I am going to discuss some problem. Okay. These are the all materials about your second exam. Okay. What we discussed in here, we started with the basic principles of counting. Then I discuss factorial and give a detailed descriptions with a visual problem y factorial 0 equal to 1. Okay. Then I discuss permutations and combinations. After permutation and combinations, few problems are solved where the word Mississippi, Tennessee, egg, sass, okay, all of those combinations in there, like different kinds of arrangement are shown in order to convince you whether it should be divided by factorial 2 or 2, factorial 3 or 3. For example, Mississippi, when one of you asks the question, if a word will have multiple repeating letters, how can we solve this problem? Then Mississippi, Tennessee, mathematics, statistics, those are the problem. Okay, then we solve one problem that has the word volume. How can you arrange the letters of the word volume when consonants are together, vowels are together, all of these things. Then we go and discuss the set theory. Set theory, universal set. Then there is a union of two sets. There is intersections of two sets. Okay. Then after the set theory, then we go discuss discuss about after set theory, then we go and discuss about random variable. After random variable, then we discuss their probability, sample space, sample points. So if 3 coins, 2 6-sided die, and 1 8-sided die will be tossed, how many sample points? Right? These are all multiplication and coming from basic principles of counting. Okay. And then we discuss how to compute the probability. After computing the probability, we discuss contingency table problem, independency of problems, and then we also discuss like the joint probability, how to compute mean, variance, and covariance when the random variable with associated probability are given. These are the all problems I have discussed. There are a lot of problems. Okay. So now let us go and discuss some problems. Okay. Clear? Do you understand? This is just a 12-page document. And then in this 12-page document, watch my video and solve all of this problem. Try to, and then your problem will be easy. Yes. Here. Okay. Last one, I will check again. Okay. Now see, if I ask you to factorial 5 equal to 120, right? So 8p3 equal to what? Factorial 8 divided by factorial 5, right? So let me do these things. Now I'm solving some problem, okay? So let me see how can we solve these things. 8p3 come in here. Factorial 8. And factorial 8 and factorial 3. Factorial, what happened? Factorial. This is the answer. Let me 6720. Factorial 3. Factorial 8 divided by factorial 5. Oh, this is factorial 5. 336. Okay. Factorial 0 equal to 1. So this is matching. So we do not need to check the fourth one, right? Right? We do not need to check the fourth one. How many different 5-letter arrangements? How many different 5-letter arrangements are there of the letters in the word moose? 5 permute 5, right? Which is factorial 5. And factorial 5 equal to 120, right? How many different? Oh, so different means distinct, right? So that means it's has to be different divided by factorial 2. Good catch. I did not see the word different. how many different 7-letter arrangement of the letters in the word hexagon? So all are unique letter. So factorial 7, right? Just factorial 7. Two cards that draw. Okay, I did not solve card problem. Do you know all the cards? Do you know all the cards? 13 cards for the heart, 13 for the diamond. You understand the card game, right? So all the 13 cards. You understand all the cards? You understand? You understand? So I cannot give the card problem in the exam then? Okay. Buy a card from Dollar Tree, $1, and then try to understand the cards. So there are 13 card which has a label heart, 13 has a label diamond, 13 has a label clubs, and 13 has a label spade, right? Spade. Okay. So each of them has a 4A, 4 king. Each card has a king, queen, jack, and number 2 to number 10. 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, 10, queen, king, and H. So this 13. So okay, let me write it here. If I want to give you a questions, so first card has name heart, 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 which is a symbol like this, and it is red. Okay, 13 cards, they have a labels A, king, queen, jack, and number 2, number 2, 3, 4, 5, 6, 7, 8, 9, and 10. These are the, and then this is called the diamond. And it has a shape like this. And this is red. And distribute 13 cards, distribution same as like this. And then there is a clubs. Is this spelling right, clubs? So clubs look like this, right? And it's black. 13 cards, it is like this. Okay. If there is a exam questions, remember these things. Okay. Heart, diamond, clubs, and then there is another one, spade. Spade, right? And spade is look like this way. Upside down. Upside down heart. So how can I draw that? Okay. And there is a leaf, I guess, something like that, maybe. It's black. So there are how many black cards altogether? 13 plus 13 equal to 26 black, 26 black card and 26 red card. 26 red cards. There are 4A, okay, 4A, red 1, red 2. I think if it will create problems for you. So what you need to remember, there are 26 red cards, 26 black cards. Black cards are known as the clubs and spade. Heart and diamond are the red card, and they have this type of symbol on the card. And the card contain 13 card for the each deck. So those are known as the king, queen, jack, and 2 to 10. Okay. So now let me go and discuss a problem. Two cards are drawn at random from a standard deck of cards without replacement. Find the probability of drawing an 8 and a queen in that order. Okay. So two cards are drawn at random from a standard deck of cards. How many ways you can draw two cards? They are asking you to find the probability, right? The 52, choose 2, right? There are 52 cards, right? Huh.
No, those are not used. No. We take the joker. Yeah.
This is serious.
I think in this problem,
They consider jokers in here?
let's try without.
No, we will do without jokers. Okay. So at standard deck of cards without replacement, find the probability of drawing an 8 and a queen in that order. How many 8? 4 8, right? So that means 4, choose 1 times 4, choose 1, right? So find the probability of drawing an 8 and a queen in that order. So this is the answer. So it should be 16 over 52, choose like that. So they did not consider jokers. Okay. So are you understanding these things? Are you okay, quiet boy? Let's see how quickly I can do this in R, right? Can I do this quickly in the R? Take a look at that. So I just need to do choose 4, 1 times choose 4, 1 divided by choose 52, 2. Okay. Crystal is making personalized invitations for a party. So she is making personalized invitations. See the word. The partygoers are Haley, Alex, Edward, Ellison, Matt, Elia, Kyla, and Lacey. 1, 2, 3, 4, 5, 6, 7, 8. What is the probability that if Crystal selects a name at random, that she will pick a name starting with the letter A or letter L? So 8 choose 1. Is this the probability? What is the probability? In the denominator, it should be choose 8, choose 1, right? Let me see. Partygoers are Haley, Alex, Edward, Ellison, Matt, Alicia, Kyla, and Lacey. So 8. What is the probability that if Crystal selects a name at random, that she will pick a name starting with the letter A or the letter L? So, or. So that means no, they said here or, right? No, so denominator is 8 choose 1. Okay. So you are saying numerator is 4 choose 1. So Edward, Alicia, LX. There are 3A and 1L. So 4 choose 1. So that means 4/8. So that means half. So that means, is this the answer? Okay. Are you getting it, what he said? Do you want more explanation or not? You're good, right? Good, right? Then there are 12 horses in a horse show competitions. The top 3 winning horses receive money. How many possible money winning orders are there for a competitions with 12 horses? So take a look at that. 12 horses, right? Only 3 of them will get reward, right? So that means 12 choose 3, right? Why? If you put 12 permutation tree, choose, that means, okay, I think you are right, 12 permute. So let me do this way. So it should be factorial 12 divided by factorial 12 minus 3. So that means 9. Factorial 9, right? Is 1320 answer? Yeah. Because it's order matters, right? Who got the first position, who got the second position? You understand, right? So that is the permutation. Brad is lining up for his golf trophies on a shelf. How many different possible arrangements can be possible? So factorial 4, which is equal to 24. Same thing happened to your phone as well?
Get close to the Moffett Health Center.
Mm. Nothing. Okay. So you got some flavor of permutation 1, right? So the documents, 12-page document that I gave, 2 lecture was to watch those things with all of your attention, and all this problem if you solve, and I think you will be okay. Okay. So this is the difficult exam, and then others exam will be, next exam will be probability distributions, binomial, Poisson, negative binomial, geometric, normal distributions. These 5 distribution I'm going to discuss the exam 3rd. Okay. And then I will go for the test of hypothesis, confidence interval, and finally the comprehensive exam. Yes. Probability, expected value, random variable. Yeah. 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 Okay. Now come, a password consists of 3 digits, 0 through 9, followed by 3 letters, having 26 letters. A password consists of 3 digits, 0 through 9, followed by 3 letters from an alphabet having 26 letter. If repetitions of the digit is allowed, but repetitions of the letter is not allowed. Determine the number of different password that could be made. Okay. And it should be 6, right? A password will have a 1, 2, 3, 4, 5, 6, right? So these positions could be occupied by one of the 10 number. This position, because repetition of the number is okay. This could be one of the 10 number. This could be one of the 10 number, right? And no, there is a one of the 26. Latter repetition is not possible. Okay, so this is 25. Okay, and there is 24. And these are all multiplication, right? Okay, but they did not mention uppercase letter, lowercase letter. A password consists of 3 digits, 0 through 9, followed by 3 letters for an alphabet having this. If repetition of the digits is allowed, but repetitions of the letter is not allowed, determine the number of different password that could be made. Okay. So it should be 26 times 25 times 24 times 1000, right? 156. Is this answer is in there? Okay. Yes.
So you said, so example two, I know you, but you mentioned.
No, those should be exam 3.
Okay, but we syllabus also said at the end subject to change, okay? But I want to make it small, piece by piece, so that whatever materials I'm giving, if we at least digest this, that will make me happy. Okay, there is a big book and like read this, and I'm not making that much. I know of my 22 years of teaching experience, I know how to give the materials to the students so that they can digest. Okay, so read like 12-page document, 10-page document. In the 4 exam, if you thoroughly read 30 to 40 pages documents and understand all of this material, that will way easier than to carry a big book and go like this way. Understand, right? So keep faith on me. So I am trying my best to give you good training, but if you understand these things, the next step will be easier. Next step will be easier. Okay. And on top of that, you are learning how to compute all of these things by using R. Okay. Now, 6 members of a school varsity fencing team will march in a parade. How many different ways can the players be lined up if Josh, the team captain, is always in the front line? This is just the volume, right? The word volume, right? So factorial 5, right? Factorial 5, which is equal to 120. License plates are formed using 4 letters followed by the 3-digit numbers without repetitions of either letters or digits. 0 may be chosen at the first digit of the number. So that means 9 formed using 4 letters followed by the 3-digit numbers without repetitions of either letters or digit. So that means 10, 9, 8 times 26 times 20 times 24. But I don't know whether uppercase or lowercase letter matter. But according to the number plate that they have shown, they consider only uppercase. A sample was given there, right? So 10 times, 9 times, 8 times, 26 times, 25 times, 24. Okay.
Determine whether the following situation would require calculating a permutations or a combination. Selecting 5 students to attend a state conference is combination, right? Selecting a first play winner and a second place winner. This is a permutation. Assigning students to their seats on the first day of the school. Permutation. A customer selects 3 different toppings for a pizza. If there are 9 different toppings from which to choose, how many different pizzas can be made? 9 choose 3. It doesn't matter whether the onion come first or right. So 9 choose 3. 9 choose 3 equal to what? 84. 84. A teacher chooses a committee of 5 students from the class of 25 students. How many different committees can be formed? So 25 choose 5. See how there are 12 juniors and 20 seniors in the debate club. If member decides to send a team of 2 juniors and 3 seniors to a debate conference, how many different conference teams are possible? So if the member decide to send a team of 2 junior, so 12 choose 2 times 20 choose 3. NCA represent the number of combinations of n items taken are at a time. What is the value of this if n equal to 4? Okay, let me write it. It is saying N C R and then R take value 1 to R take value 1 to 3 and then N equal to say it 4. N equal to 4. So now I want to do it here. 4 choose 1 plus 4 choose 2 plus 4 choose 3, right? 1, 2, 3. So this is equal to 4, this is equal to 6, this is equal to 4. So 14. 14 is the answer. Okay. Let me see. Okay, here is the thing. I actually generated it from there, so that is why this thing showed up in there. Here. Let me see whether it will work or not. Yes, it is working now. And then another one is X. Where is that one? That one, that one, that one. Here is Y. Yeah, so I think I fixed those things. Now you can have this. Let me save it in here. So in the next class, I will discuss set theory, joint, and problems of probability. So you said problems of probability is not working? Okay, so let me see again. Okay, I'll check it. So here is the thing that I want to download. I just downloaded that part. Now let me go there. That has been deleted. I want to name it as a, let me upload it, then we will update it. Let me go there. Let me see that it is open or not. Just a second. So let me upload it. Go to the courses, that one, then module, and then I can remove these things and add it in here. File, create file, choose file, edit, add them, replace. Okay, this is done. And then I have in here modules. Okay, 2 typos are done. I will upload the today's class in there. Okay, are you saying this is module 3 for the today is the 6th week, right? This is the 6th week, and then 7th week is in here. So and then module 4 will be for the 8, 9, 10th week, or maybe 8 and 9th week, maybe 9th and 10th week because 7th and 8th week I will not take the class. I will give you free time so that you can practice. Okay, and then module 3, 4, and then 5. After that, there will be comprehensive exam. But the comprehensive exam, if you perform very well, I'll be super happy because this will be a combination of everything, right? So just the documents that I provided, read those things, watch those things, keep your temperament cool, and I think you will be okay in doing good in your exam. Okay. So let me